Everyone, we will solve this today's LeetCode problem. This is LeetCode medium one, but believe me, I don't know how this is a medium one. Uh, it should be it should be marked as a hard. It should be marked as hard. It don't have a simple approach. It it has mixed of two two more than one approach, right? So it should be marked as hard, although it is a very good problem. It is a very good problem to solve. But if you mix two concepts together, then this problem can be only solved. So I also took around 20 minutes to solve these problems, not due to logical, but for implementation part, I was getting so much error. So I take 50 to 18 minutes at most, I think. So yeah, so let's see what it is, right? So it's a very good problem. So you can mark this as a favorite one. I also mark this as a favorite one, right? So yeah, that's how this goes, right? So let's see. 1 to find the surface path in the grid. So we have given a zero index 2D matrix grid of size n cross n, where RC represents a cell containing a thief if grid RC is equals to 1, an empty cell if grid RC is equals to 0, right? So the one which is denotes the thief, and the 0 which denotes the empty cell. So you are initially position at 0 comma 0, and in one move you can move to any adjacent cell. Adjacent cell means you cannot move diagonally, but in all the four direction, right? That was the adjacent cell means. The safeness factor of a path on the grid is defined as the minimum Manhattan distance from any cell in the path to any thief in the grid. So, what is the Manhattan distance? So, Manhattan distance is absolute difference between the two values. If the two cells has A, B, and X, Y, so absolute difference between A minus X and B minus Y is a Manhattan distance, right? So we need to find the minimum Manhattan distance from any set in the path to any thief in the grid. So from 0 to 1, the Manhattan distance is 1. From this 0 to 1, the Manhattan distance is 1. But from this 1 to 0, the Manhattan distance is 2, because this if you take 0 comma 0 and this is 1 comma 1, so 1 minus 0 is 1 plus 1 minus 0 is 1. So from this 0 to this one is Manhattan distance is 2. So this is how Manhattan distance is calculated. We need to find the maximum safeness factor of all paths leading to n minus 1. So the problem is that we need to move to 0 to n minus 1 and find the maximum safeness factor safeness factor of any path we choose, right? And what is the safeness factor? Safeness factor is the minimum Manhattan distance. Safeness factor is minimum 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 Manhattan distance, right? And Manhattan distance from which? From Manhattan distance from any thief which is present in grid, which is present in grid. So this is all the gist of this question, right? This is all the gist question. So if you see here, we need to find the maximum minimum Manhattan distance from anything which is present in grid of any path we choose. If you combine these two, you need to find the maximum minimum Manhattan distance from anything which is present in grid, right? So the one thing after this, you so if you see an example, suppose here in this case the 0 comma 0 is at one position. So the thief is at position at 0 comma 0, so the answer will be automatically 0, because this is the uh, we can't move to this n comma n minus 1. We can't reach to n minus 1 because the thief is at present as 0 comma 0, so the answer is 0 here. But if you see in this example here, this 1 is at here, right? So if I choose this 0, then 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 this 0 have Manhattan distance with 1, this as 1, right? Which is not a maximum, which is not a maximum. But if I choose this path which is colored in this dark. So if you see, every zero is at minimum distance at, so the maximum the minimum distance which is present is 2. So if you see, this is present at 2, this is present at 2, this is also present, sorry, this is not, this present as 2, this is present at 2, and these all are greater than 2 Manhattan distance. So the minimum value which is the empty cell which is at minimum distance with maximum distance with this thief is this 0. Understood? This 0 is at 2, this is greater than 2, this is greater than 2, this is greater than 2, but this is at 2. So the minimum distance which is at in this path is 2. So the maximum safeness factor is also possible with 2 only. But if you choose any other path, that will take one value. So if you see here, so I need to find that path. I need to i need to find that path which is whose empty cell in that path, the empty cell which contains in that path, whose empty cell which contains in that path should have, should should have the minimum, sorry, should have the maximum distance, right? Maximum safeness factor, or you can tell maximum Manhattan distance. So if I choose any path, so we consider the overall minimum distance between overall distance between between all the empty cells in that path, in that path all the empty cells that path to any of the nearest thief. And and after choosing distance for a specific path, we need to we need to take a max of all the minimum distance which we have calculated for all the paths of each path. So the max, so what need to find, we need to find the max of all minimum distance. This seems to be confusing, but if you really really repeat again, uh, you will feel like what we need to do. We need to choose any path, and we will consider all the distance which is for every each cell empty to thief cell, and find the minimum distance from there, right? Because that will be the distance which is for the that path specifically. And after choosing all the paths and finding all the minimum distance of that path, we need to find the max of all the minimum distance which we have till now. So that will be the that will be the safest factor, right? That will the safest factor. I think you understood this, right? What we need to do, right? Suppose I have started choosing this zero, then zero, this zero, this zero, in the example two, in the left side. If you see, this zero, then this zero, then this zero, then this zero, then this zero. The For this path, the minimum distance is what, one. From this zero to this one, from this zero to this one is one, right? But if I choose this, then what will the minimum distance? That is 2. If you see any of the thief from here and at this path, then you will see that the minimum distance of any cell is 2. This is 2, this is 2, this is 2, right? So for this path, the Manhattan distance is 2. So for this path, the minimum distance is 2, right? So that will be the uh, minimum distance of 2. For again this path, this is also 2, the minimum distance of 2. So for this path 1, for this path 2, for this path 2. So the maximum of all the minimum distance is 2. So that's why the safest factor is 2 here. I think now you have got understood for this. I tried enough to understand make you understand that maximum of minimum distance is what, right? Now the main thing is, so what will, if you observe that, what we need to do, we need to find each and every empty cell distance from its nearest thief. One thing is clear, we need to find the maximum when the uh, distance of empty cell from its nearest thief, right? So this is clear, right? So once I have find the empty cell distance from its nearest thief, then how will I get to know that the maximum surface factor is what? So if you see here 0 comma 0, okay, or let's take another example, or let's take this example as third, right? So if I find all the near all the distance of the empty cells from its nearest thieves, then after calculating that, how will I know the maximum surface factor of a path? So I have all the distances, I have all the distances of every empty cell, of each and every empty cell, right? Each and every empty cell, each and every empty cell. So that is, I'm sure that that is sure so finding this, I'm sure that I have this distance, I have for a particular empty cell, I have a distance which is at minimum distance to the thief, right? I have find the maximum distance which is a minimum distance of thief, right? Now I need to find the maximum safest factor. So I need to start from zero, that's for sure. So when I start from zero, I see the maximum safeness factor. So the one thing is clear here. The one thing, one observation is clear. One thing is clear, that the maximum safeness factor which we can achieve, which we can achieve is the distance of 0 comma 0, the source path, this is the starting position, this is 0 comma 0 from its nearest thief. Do you agree with me? Do you agree with me or not? Of course not, because this zero is, if I started from this and its nearest path is uh, the nearest thief is anywhere, that will be the maximum safeness factor. Because I need to start is here, I cannot start from anywhere, I need to start from here. So the maximum safeness factor we can achieve is 0 comma 0, right? This is clear, I think this is clear. This should be clear in your mind that the maximum safeness factor which I can achieve is this part. Now I need to find a path where I need to find the maximum safeness factor. So I have this maximum safeness factor. So my and so my maximum safeness factor value is this distance of 0 comma 0, right? This is the ultimatum. Now when I started moving in path, when I started moving in path, so while moving in this path to n minus 1, if I started if I started go through only only that path which has the maximum distance between its thief. So what does it mean? Suppose this is 0 0 0 and this is 1. This is 0, this 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 0, and this is 1 0 0, and this is 0, right? So for this 0, the nearest thief is at 3. So for this is 3. For this is 2. This is 1. This is 0. Because this is at one position, so this is 0. Again for this, the same thing, 2, 1, 0. For this, what will be the answer? The minimum distance is at 2 plus 1, 3. Understood? No? This should be 3, right? This should be 3. This should be 3. For this, 2. This is for the same, 3, 2, 1. No, this should be not 1. This should be 2, 3, 1. Sorry. Uh, yeah, this should be 2, 3, and this should be 2. Right. I think, yeah, correct. Correct. This should be 3, because this the minimum, the nearest thief is this one. So that would be, so this is 0 comma 3, 0 1 2 3, 3 minus 0 1 2 3, and this is 0 1 2. So this is at 0 comma 3, this is 0 comma 3, and this is at, this is at 0 0 1 2, 2 comma 3. So that will be 2, and this should be 3. Yeah, right, correct. So 2 comma 2, which is 2 3 minus 2 minus 3. Yeah, correct. So this is the distance which is at here, right? So this is 1 2, and this is 3. So this is the distance for all the cells for the nearest 3, right? Let's remove this. So now what I need to do, the maximum safeness factor which is at 3. So the maximum distance is 3. So maximum safeness factor which is starting at 3. Now I need to take that path which will give me to n minus 1, and which will give me the maximum safeness factor. So if I started from 3, I can go to 2, and this 2 also, right? uh, Here is written that we can only go to adjacent cells, we can't go to diagonally, so we can't go to this right, these 3. We can go to this 2, this 2. So we will move to this 2, right? Now the maximum safeness factor becomes 2. Why? Because this is the minimum, this is the less than this 3, so this is becomes 2. After this 2, I can go to this 1 also, I can go to this 3 also, but this 3 is greater than this 1, so I need to move this here 3. So for this 3, I can move to this 2, I can move this 2, but I cannot move this 2 because this is really the visited path, right? So I will move to this 2. So I move this 2, and I can move this here, 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 and plus upper. Then this 3 is the maximum distance, maximum safety factor, so I moved it to 3. For this 3, I can go to this here 2, this 2, and down 2. All are same, so I will move to this 2, and then I can go to this 3. So I achieved this n minus 1. So the maximum factor of this path is, the maximum of the minimum of this path is 2, which we achieve. So now the problem becomes that, uh, now the problems simplified to this only, that we have given distance and we need to find the maximum. The problem is now, the problem concludes to, the problem concludes to that we have, uh, we have distance given, we have this number given, we have numbers given, we have numbers given in grid, and we need to find the max number of the path from 0 to comma to 0 to n minus 1. Now the question simplifies to this only after calculating all the distance, right? Now the same question simplifies to this. So I need to find the max number of max number of path, max number in any path from 0 to n minus 2, right? So uh, for calculating that, what I can take, so I can move to any direction, right? So when I move to any directions, how will I know that which path will contain the maximum number dynamically? So if you see, one data structure will help us here, which is maxip. Do you know what this maxip do? This will give us the maximum value, which is this will, the top value will be the maximum, this will give us the maximum value which is inserted in this, right? So suppose I started from this 3, then this 3 inserted in heap, right? This 3 is inserted in heap. So when I go to this two or this two, the both is same, so I can go to anywhere. So I inserted both of this here. I inserted both of this here. So I from this 3 comma 0, I can go to both of the places. So I inserted all of this. So that will be 2, that will be 0, that will be 1, right? And I can also go to below part. So this is 2, this is 1, this is 0. So this, what this denote, this is coordinates. Because how will I differentiate this between this 2 and this 2? According to coordinates only. So I need to store this also, right? So after this, going to 2, I can, for this 2 0 comma 1, I have 4 3 pass again, because I can't move to this 3 because it is already wasted. I can go to this or this, right? So this 3 is, I can go to this and this also. So I will move to this 1 and 3 both. But heap will give us 3 at the first part. Why? Because this 3 is the maximum, this with this one. So this 3 will give us the maximum value. So why, that's why I'm using heap instead of using a priority queue. Sorry, instead of using a simple BFS, because this 3 will give us the maximum safeness factor which we need. So this is, if you see here, this is something like, this is something like Dijkstra algorithm. Don't you think? Dijkstra algo. Don't you think? This is something like Dijkstra algo. In Dijkstra algo, what we need to do, we find the minimum distance, right? We find the minimum distance, but here we need to find the maximum distance. So for that, I take maxip instead of min. That's the change in this Dijkstra, from the standard Dijkstra, right? So we will store all the coordinates with its distance and store in maxip, that so that the first thing which I get is maximum value. And then when I reach to this n minus 1, I'm assured. And when I reach to this n minus 1 to n minus 1, I'm assured I'm assured that the first time when I reach when I reach that will be my max safeness factor. Max safeness factor. That will be my safeness factor. I am assured, because I am storing it on in all in max heap, and that will give me always a maximum value on the top. It doesn't matter that what values are we have inserted till now, right? That will give me the maximum safeness factor till on all over the period. So, but one thing is here, that how will I maintain this maximum safeness factor? Because after this 3, this is here is 2, and when I go to this one, this should be 1. This should be from this to this to 1. So what I need to do is here, I need to I need to store the, for this, suppose this, for this is 0 comma 1. So for when I go to this one, this should be the store the minimum value. This should store the minimum value between this 2 and this is 1. So that should be 1, and this is 0, and this is 2, right? Right. So after this one, suppose after this one, after this one, I can go to this 2 also, right? So when I go to this 2, this should store the minimum of between 1 and 2, not this 2 directly, because we in this path 3 2 1 and 2, the minimum is 1, right? So uh, I need to maintain this minimum value in my priority queue, so that I can return this at last when I reach the maximum safety factor, right? So I will move to this 1 comma 2. So in this one and in this 2, this 1 and 2, the minimum distance is 1, so I need to store this 1. So this is how we use maxip and this. Okay, one thing is left, I haven't told you, that how will we find this distance, this 3 to 1 and this is 0, right? So we need to calculate the distance of empty cell from its nearest heap. So if you have so if you have solve the problems on multi-source BFS problems. So that is the same part. What we need to do, we will insert all the thief, marked all the thief as zero, right? We have marked all the thief as zero. We will mark all the thief as zero, and we will this one, and we will start iterating in all the four directions according to the cells of one, right? So in this here, this cell and this cell, what will they give? So this will leads to one, this will leads to one, this will be two, right? So this is the multi-source BFS. So see, this is the hard problem. I understood this is the hard problem. You need two things clear: Dijkstra's plus this multi-source BFS, and both the concept uh, is on another level, right? So I understood that if you have difficulty to solve these problems, you can first solve this on multi-source BFS problem, then Dijkstra again, and then solve these problems. Right? So we have started from this one and this one. So for this zero, so for this one, this is zero distance. For this one, this is one. This is for two, and this is again for three. And for this is one. Okay, and this is two, and this is at three. Right, this is at three. For this here, this is zero. So for adjacent part is one. So this will be marked as one. This will be marked as two. Right. Now again for this is marked as one. Okay. This should be marked as one. This should be marked as two, because from this one the nearest thief is this. So this will mark as two. And again for this, the two and two, this will be three. This will be two again, because before this three, this one will reach to this cell, right? And after this three, this will be this is two, this will be three. So this is how the multi-source BFS works. We insert all the cells of one, and we will iterate in all the directions and increase these cells, right? So uh, I try to explain you all the things, but let's go to implementation part, and that is also very large. So I decided to uh, show you the code only and make you understand, which I have already solved here, right? Which I have already solved. So I decided to show you this. So let's use my code, which I have tried, which I use for solving, which I solved just before this, and making you understand. So let's go to this. So the first thing is here. The first thing is we need to find the distance of all the empty cells from this thief, from all the thieves nearest thief. So for that, I use a queue for multi-source BFS, multi-source BFS part, right? So I've inserted. Okay, the first thing is also here, that here it is given that the thief is at one and the cell is at zero. But for using this same grid, I need to change this one to zero, because the source distance will be zero, because the thief is the cell, from the thief we need to find the distance to empty cell. So for that thief I marked this zero, and for empty cell I marked this minus one, right? Why? Because why have changed this? To find the distance from thief to empty cell, nearest thief to empty cell, right? So the nearest thief's distance from the thief is itself zero, that I have marked as zero. I inserted in our queue data structure for traversal. So I inserted marked as zero for distance, and also inserted in queue data structure, right? Now, and for zero I marked as minus one, because that will overlap. That's why this is the first part which I need to implement. For this is for the implementation just part. I We can also take an extra vector, but that will increase our space complexity, but I use this input value, right? Now I will iterate in BFS. This is a simple BFS part. So in this vector, what is here? In this vector, we have a distance, we have the coordinates x and y, and also the distance, minimum distance I have stored. So the first thing which we are doing, we are iterating in all the four directions. For that, I have make this at dynamic, and we are iterating in all the four directions and checking that with this whether this new coordinate is valid or not. And also we need to check that whether this grid is already visited or not. So what does how we will check that whether this whether any cell is visited or not? How we will check? How we will check that whether any any cell is visited? So what we are doing, if you see here, the empty cell has value -1 in grid, and the thief is as 0. So if I have any distance, any values other than this -1, other than this -1, it means we have already visited, because any value which is at any cell which has some numbers other than -1, it means they have already visited, and right. So if that is not -1, so if that is wasted, it means that will be not -1, or then we will continue this, right? Otherwise, we will increase by 1, because this and this cell has one distance, right? So we will increase the because so this distance is from parent, and we are coming to this adjacent part, so that need to increase by 1, and I will store this in my QData structure. And this is how we will find all the distance in the same grid. So from this it goes changes to this. Now I need to do something to this to find the maximum safeness factor. So till here this is for calculating the distances. So this is for calculating 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 the distance of empty cell from its nearest thief, right? This is for calculating the distance. Now now I need to find the maximum Manhattan distance. For that, I told you to use a maxi. Why? Because I need a maximum safeness factor, and that this will give me surely the maximum value if I choose the path. So for that I need to choose a path. So I need to, this is the same thing, that I need to go to from 0 to n-1 to by seeing the maximum, by taking the maximum safeness factor. So I choose a priority queue and inserted the source. The source is at source this 0 comma 0, and I have inserted this grid 0 comma 0 0 comma 0. That will be the maximum safeness factor we can achieve. It's not sure that I can achieve this, but I'm sure that this will be the maximum safeness factor I can achieve. Beyond this, no any values can be achieved, because this is the source point, right? So I inserted this, and I also mark this as visited by marking this as -1. Why? Because so that I will not move this cell again, so I need to mark it as visited. So I'd use this same grid. You can also use another vector, another visited array, but that will be give this that will be generate the extra space complexity, right? So I've used this again to mark this as visited by -1. So I started iterating in priority queue, and I stayed in all the four directions. This is the same thing which we are doing here in all the four directions. The difference is here that I need to push the minimum between the distance which is currently and the new distance which is we are doing. Why? Because if you see here, I told you that from this one, when I move to this two, so the safeness factor will be still 1, because in this path 3 to 1 and this 2, the 1 is the minimum. So I need to maintain the safeness factor now. I need to maintain the minimum safeness factor, so that when we reach this here, so I know that at which the path which we are traversing to this three to and bottom right value, to this end value, the what is the minimum stiffness factor we got in this path. So I need to maintain this in my path, so I need to take the minimum of 1 and 2, right? So I need to take the minimum of all the stiffness factor, so that will include this one at here. So that's why I need to insert the minimum between the distance which is at current, and after moving this new cell grid, and store this minimum value in my my new coordinates in my priority queue, so that it will give me a maximum value when I go to end, right? And we'll mark to is visited also, right? This is for marking visited, marking visited, right? So, and after this, when we go to when we reach to the bottom right, which is n minus 1 and n minus 1, we will return this distance. So the distance is here is safeness factor. Distance is here, distance is here, is safeness. Here distance is safeness factor, right? So we will return this distance, and so this is the safeness distance, right? And if I don't able to reach to n minus 1 anyhow, that will give me, after this I will return just minus 1, because that will be so for this condition it is at the starting position 1. So after this I will not able to move to any part, so the safeness factor will be 0, right? That, so that will automatically be handled in this, because grid 0 comma 0 is already marked as 0 in the starting point. Understood? So this is how we solve the problems, right? Hope you understand it. uh, I think I okay I let's analyze this time and space of complexity also, right? So the time complexity is the first thing we are doing. This is O of n square to change all the things and inserting the queue, so that will take O of n square, O of n square, right? Again, for inserting in queue data structure and traversing in all the directions. So already we have not wasting the same cell again, so that will again take O of n square, that will again take O of n square. Now for okay, now for finding the safeness factor, we are using priority queue, and we are moving in all the directions and inserting all the cells in my priority queue, and we are not wasting again and again. So that, so for each cell, for inserting, for inserting each value in heap, it takes log of n, log of value, right? So we have O of n square cells, and for each and every that will take O of log n, so that will be O of log of n square. So overall the time complexity will be O of n square log of n square, right? So this is will be the, for inserting it will take log of n. So the total number of elements is n square, so that's why it takes log of n square, right? So this is this is the time complexity. And what is the space complexity? So the one thing is clear, that we are not using any extra wasted cells, marking wasted. We are using this grid. We are using a queue data structure here, that is inserting all the values in queue. So that will take O of n square, right? And again I am using a heap, so that will again take O of n square. So that will be again O of n square only. So this is the space and the time complexity for this question. Hope you understand it. If you understand it, let's comment understand, so that I know that whether this all the time and effort benefits you or not, right? This is a hard question, I am sure, but solve this Dijkstra algorithms if you haven't solve this multi-source BFS problems if you haven't solved, and then solve this problem. I must insist you. Right. Thank you. Bye bye. Have a nice day.